Hello, everyone. Welcome to this session on everything you want to know about GitOps. My name is Janakiram. I'm based out of Hyderabad, India, and it's my pleasure to be a part of the Deploy conference by DigitalOcean. Actually, it's a tall promise to make to say that we are going to cover everything related to GitOps in just 20 minutes. So that's going to be pretty hard. But nevertheless, I'm going to try my best to cover the essential concepts of GitOps, including a live demo. So I'm keeping my fingers crossed because this is a complex demo, but I'm hopeful that I'm going to finish everything in 20 minutes and leave you with a good understanding about GitOps. So if you are familiar with Kubernetes, you know there is something called desired state of configuration, particularly a set of workloads like deployments, replica sets, stateful sets, jobs and cron jobs, daemon sets. They all are very unique in a sense that when we define them, we also define the configuration state. For example, how many replicas within the deployment and how many pods within the replica set. And the Kubernetes controller will ensure that even if the configuration drifts away, it brings it back to the original definition, original spec. That's the reason why when you delete a pod that belongs to a deployment, it automatically shows up. That is the advantage of the controller manager. So the controller manager relies on a database, which is acting as a single source of truth, and that is XD. So XD is the key value database that is available to all the components of the cluster. And when a pod is deleted, it is written to XD, and that's how the controller manager will get to know that there is a change in the configuration, and it reconciles and brings it back. Now, how about extending this ability not just to the controller manager managed workloads, but even cluster-wide resources, for example, the namespaces, config maps, and even RBAC, which are not typically monitored and managed by the controller manager. So for that, we obviously need to move away the source of truth into a more centrally available location. And we need to extend this further. What is better than Git, which is the universal single source of truth? Today, a lot of developers, a lot of administrators, and a lot of enterprises rely on Git as their single source of truth to manage their source code, to manage artifacts, and the versioning system and the workflow involved with Git has been universally accepted and appreciated. So why don't we consider Git as our single source of truth and maintain the desired state of configuration across the cluster, or in fact, across multiple clusters centrally in the repo? So the Git repo becomes the single source of truth for the entire cluster, and the YAML artifacts or Helm charts, whatever you use to configure your Kubernetes deployments and policies, are going to be centrally managed in the Git repo. And as soon as you modify them and perform a commit, just like you do Git commit and Git push, it automatically flows down to the cluster. An agent will listen for the changes, and as soon as there is a commit, it pulls those changes and applies them. And not only that, when the configuration drifts away from what is defined in Git, the agent running inside the cluster automatically reconciles that. So that means just like the Kubernetes controller manager, you can define things like namespaces and config maps and ingress and so on, and also monitor them for drifts and let the agent automatically reconcile this state. So this is a very powerful concept, and this also provides the advantages of abstracting access to your Kubernetes cluster through Git and take advantage of some of the workflows that Git offers, like creating a pull request, accepting the pull request and merging that with the main branch, and then automatically kicking off a rollout or a deployment. So GitOps is becoming the next generation in infrastructure as a code concept, infrastructure as code concept. We have seen Terraform and Ansible playbooks, Puppet, Chef, CloudFormation templates. Now think of GitOps as the next generation of infrastructure as code, where we are leveraging Git as a single source of truth and maintaining all the artifacts centrally in a repo. So defining GitOps is straightforward. It's a way of implementing continuous deployment for cloud native applications by using tools that you're already familiar with, which are basically Git and some of the existing continuous deployment tools. And in terms of the big picture, if you're familiar with CI/CD and DevOps, GitOps is the last mile. Think of it as the release management workflow. So your CI system continues to monitor your Git commits, build images, pushes them into a container registry, and that process will continue to exist. But as soon as the YAML files or the Helm charts get updated every time there is a build, it is going to kick off the continuous deployment workflow. So, that is what is the role of GitOps. Think of it as the last mile delivery vehicle, and it is complementing continuous integration of technologies like Jenkins or GitHub Actions in making sure that the updated artifacts living in a Git repo are automatically applied to one or more clusters registered with the GitOps workflow. So, Kelsey Hightower calls GitOps as a version CI/CD on top of declarative infrastructure, and it's a very apt way of putting it. So there are certain principles coined by Vworks, the company that pioneered the GitOps evolution and pretty much build the tooling and the ecosystem around it. So there are 4 principles. The entire system is described declaratively, whether it is a Helm chart or YAML or a customized file, everything, or a JSON file, everything is available declaratively. And it is canonically maintained and versioned in Git. No brainer. It is GitOps, and Git is a single source of truth. The changes that are accepted and approved will be automatically applied to the system, which is the cluster, or it could be even non-Kubernetes environments. And the software agents are responsible for listening for these commits or polling the Git repo and automatically apply the changes and manage notifications when there is a drift or when there is a failure in the rollout. So Flux is the tool for GitOps. Again, it was created by Vworks. Now it is one of the popular tools. It's a part of Cloud Native Computing Foundation. It is used by a variety of platform vendors, including Microsoft, Amazon, VMware, and many other startups. So Flux is basically the software layer that implements GitOps. So the Flux agent is going to live inside the cluster, and it is going to be listening or polling the centralized Git repo. And as soon as there is a new build, there is a new commit, it pulls the image and applies that to the Kubernetes cluster. So that is the basic conceptual understanding or the background that you need to know about GitOps. Now, nothing like seeing a live demo. And I want to quickly switch to a live demo and show you an environment that I have here. So this is DigitalOcean Deployment Conference, and obviously I'm using DOKS, DigitalOcean's Managed Kubernetes Service, to run 3 clusters across Bangalore, Singapore, and London. These clusters are not running any workloads, any deployments, but I just deployed an ingress because this is going to be the endpoint for the web workloads that we're going to deploy. So we have 3 clusters and 3 ingress endpoints exposed via DigitalOcean's load balancer. So that's the infrastructure we have. Now, what I'm going to do is take the Bangalore cluster and bootstrap it for Flux and enable it for GitOps. So let me switch to my script. To save time, I have already created the commands or the script, so I can quickly copy and paste. So I'm going to basically switch to my local Git repo, which is initiated. And currently, I don't have. Okay, so currently, when you look at my local Git working directory, I have something called fleet, And this is responsible for holding all the configurations and deployment, or rather the cluster bootstrapping components. So what I'm going to do now is to use this, and also let me show you the GitHub repo responsible for both the cluster bootstrapping, which is deploying Flux, and also the workload that we're going to launch. So currently, when we look at the namespaces in the Bangalore cluster, we don't have anything here except the ingress system, which is the ingress that I have deployed. Now, let me go ahead and bootstrap Flux. So when I run this command called Flux bootstrap and follow GitHub as the repository, I give the repo name, which is do deploy demo, and the path where I want Flux to store the manifest responsible for bootstrapping is fleet BLR1. So let me run this command, and as soon as I run this, it's going to basically commit certain files, certain YAML files into this repo. And immediately you notice there is a new namespace called Flux system. So Flux system is now created by the CLI that I ran. And what it basically did is it took the repo that I pointed it to and committed a bunch of files and used those files to bootstrap the cluster to install the agent. So now when we come back and refresh and look at the fleet directory, you see that all the three clusters, BLR1, London 1, and Singapore 1, have this directory called Flux system, and they are just added now. I already onboarded the remaining two clusters to save time. So now we have three clusters running the Flux agent, the GitOps agent inside the Kubernetes environment. Now, the next step is to basically deploy the software. So I'm actually running a web application called Task Dash, which is a simple application to create a task list and maintaining that. So for that, what I'm going to do is, first let me start by running git pull to make sure that my local directory is up to date. And then I'm going to simply create a directory called config, in which we are going to keep the configuration and deployment artifacts of my web app. So what I'm going to do is from my staging directory, I'm going to dump all the YAML files into config. So how does that look? Well, these are the YAML files that I just added to my local repo directory. So there is a web deployment, there is a web service, which is exposing the actual application. There is an ingress. There is a PVC that I'm creating based on the DigitalOcean block storage device. There is db.yaml database, which is MongoDB exposed as a service. And then there is a file called customization. So customization is the critical factor that is going to, that's basically an engine, which is template-free engine, which will aggregate and consolidate all the customizations that we apply, without writing complex template logic. So that is the workload that I have added to my local directory. Now, what I'm going to do is, okay, let me make sure all these files are in the config directory. Excellent. Now I'm going to add this to my repo. I'm going to run git commit and then finally git push. So when I do git push, interesting things happen. Now, obviously the repo is updated. You can actually see that the config repo is now having all the artifacts. And what I'm going to do now is to quickly connect that repo with the Flux agent. Now I am informing Flux that, pull all the artifacts that are added to the Git repo. And the command here is basically pick up from this repo and use the artifacts coming from config. So I'm going to run another command, which is going to basically connect the config path of the repo with my local cluster. And As soon as I do that, you notice task dash namespace getting created. And that is because we already have that defined in the YAML file, and it actually shows up here. Excellent. So now when I actually come back and do a refresh, we should see the web application in just a few seconds. So now let me show you what's inside the task dash namespace. So the containers are being created, the pods are being created, and there we go. Now when I come back and do a refresh, hopefully this should, there we go. So here we have the simple web application. So I can say commit, build, and deploy. So this is my simple application meant for managing task lists. So we deploy our first application via GitOps workflow into the Kubernetes cluster. So now I want to show you something interesting. So this application is now deployed across 3 different locations. Now Task Dash is a global SaaS company, and they are running across the globe. So you notice that this is the Bangalore front end, this is the Singapore one, and this is the London. So now let's go ahead and use GitOps to perform deployment at scale. Now what we want to do is, as a company, we want to roll out V2 of the web application across the globe, across the planet, with just one commit. So we are back in the same directory where we have our YAML files, and this is my local Git repo. So what I'm going to do now is to open the web.yaml file and simply change the task dash tag from V1 to V2. So I have now upgraded my image. This could be a pull request as well, but to keep it simple, I'm going to modify the source code, and then I'm going to add this, and I'm going to commit by saying, oops. Okay, so I'm going to commit by saying upgraded to V2. And here is the final moment, the moment of truth. So git push. Now one git push will perform the deployment across 3 clusters running in 3 different regions. Now I put these browsers in auto refresh mode. So in just a few seconds, we'll actually see that all the 3, there we go. So now Singapore got upgraded to V2, and in a moment, we'll actually see the other locations also getting the update and becoming, there we go. So this is okay, perfect. So now I have shown you how you can actually do deployment at scale with GitOps and using Flux. So we rolled out a new version across the globe, multiple clusters. Now to keep this simple, I'm showing you only 3 locations and 3 clusters. This could be hundreds and tens of thousands of clusters connected to the same Git repo and using the Flux agent, and you can perform deployments at scale. So fantastic. I'm so glad that all the demos work the way they are supposed to be. And that brings us to the last slide. So, GitOps combines the power of Git and Kubernetes API. On one side, you have the Kubernetes API. On the other side, you have Git. GitOps sits right in between and brings best of both worlds. So Git becomes a single source of truth to maintain the desired state. If I go ahead and delete one of the artifacts or one of the resources in Kubernetes, it automatically reconciles and shows up. So GitOps is a very secure, reliable, scalable, continuous deployment mechanism. You don't need to expose your Kubernetes clusters to developers or third party to perform deployments. And behind this magic is Flux, an open source tool to implement GitOps in Kubernetes. The agent periodically pulls the configuration from Git and applies the changes to the local API server, and it also monitors and maintains the desired state of cluster. If you are interested, you can visit fluxcd.io and learn more about it. So it's a very short session to give you an end-to-end overview of the GitOps demo. So that was my timer. It just went off saying my time is over. So I hope you found this session useful. Now we are open for Q&A.